Okay, so hopefully you watched the first video. I'm going to do a couple more examples with long division. This is a case where the degree of the numerator and the degree of the denominator, I'm going to try and stop this autofocus, it's zooming in and out, it's driving me nuts. The degree of the numerator and the degree of the denominator are equal, but the denominator is not a single variable. So, actually I need to zoom in here. I'm going to see if I can zoom in. Can I do it on the fly? I can. There we go. Okay. So we're going to need to do long division. Okay, so x minus 1 is going to divide into x plus 1. So let's think about this. What can I multiply x by to get x? Well, that would be 1, and it's a constant, so I can line it up over my constant. 1 times x is x, 1 times negative 1 is negative 1. I subtract, x minus x cancels, 1 minus negative 1 is 2. So this integral can be rewritten as 1, our answer, plus our remainder, 2, divided by our divisor, x minus 1. And I'm going to split that up further. I'm going to split this up into 1 dx plus 2 times the integral of 1 over x minus 1 dx. So I pulled this 2 out in front because it's a constant, and I rewrote that as 1 over x minus 1. This becomes x. This, again, there's that natural log, 2 natural log of the absolute value of x minus 1 plus c. Once you do a couple of these, and you start to see the patterns, it's actually not that bad. It seems a little scary at first. Okay, let's go do number 5. Whoa, that's not number 5, that's number 21. What happened to my number 5? I lost my number 5. Let me pause while I find my number 5. Okay, have no fear, I found number 5. Actually, I'm going to come back, I'm going to do number 5 last. I'm going to do number 7, and then we'll come back and do number 5. Okay, so again, I look, it's a rational function. I can't do any of the normal things. I can't split it up because I have more than a single term in the denominator, so I can't use that strategy. U substitution is not going to work here because I would let u equal this, which would put my du down here, and I can't have du in the denominator. And it's definitely not a trig identity, so it's none of the 3 from our warm-up in the last video. So that means I'm going to have to do long division because the degree of the numerator is bigger than the degree of the denominator. It's top-heavy. So I'm going to divide x minus 3 into x to the third minus 3x squared. Uh-oh, I'm missing an x term, so I have to fill in plus 0x plus 5. Hopefully you remembered that from pre-calc last year. Okay, let's divide. X goes into x to the third, x squared times. X squared times x is x to the third. X squared times negative 3 is negative 3x squared. And I subtract. X cubed minus x cubed cancels. Negative 3x squared minus a negative 3x squared, that also cancels. So that's 0. And I bring down the next term. Well, what can I multiply x by to get 0? I'll call it 0x squared. What can I multiply x by to get 0x squared? Well, if you said 0x, you would be absolutely correct. Okay, so now I'm going to do 0x times x, which is 0x squared, 0x times negative 3, which is also 0x, and I subtract. Don't be afraid to write all the zeros in there. These guys cancel. 0 plus 0, or 0 minus 0, is still 0x, and I bring the 5 down. Okay, so let's see what we got here. What can I multiply x by to get 0x? Oh, that's a 0 again, isn't it? 0 times 0x, or x is 0x. 0 times 3 is 0. We subtract. 5 minus 0 is 5. I have some room down here. Instead of cramming it over here, I'm going to come down here. So this integral can be rewritten. I'm going to go to a darker color here. Our answer, which is just simply x squared, plus our remainder, 5, divided by our divisor, x minus 3. So, if I'm doing this on the AP exam, I've done enough of these problems, I recognize a pattern, I'm not even going to bother splitting it up. I can say the antiderivative of x squared is 1/3 x cubed. I know that 5 can be pulled out, so this is plus 5 times the natural log of the absolute value of x minus 3 plus c. And that's it. Okay. Now I'm going to go back up to 5 here. This one's interesting because this does not fall into the degree of the numerator is greater than or equal to the degree of the denominator. So this is kind of an odd strategy, and if you were having multiple choice questions, I would maybe expect to see this as a multiple choice question. I can't imagine that they're going to do this in a free response question. However, in the event that they do, I at least want to show it to you so it's tucked in the back of your mind somewhere. I can, if I have 3 plus 4 over 7 plus 9, I'm allowed to split that up into 3 over 7 plus 9 plus 4 over 7 plus 9. I'm allowed to do that because they still have a common denominator, so I can add them together, right? That same idea applies here. I'm going to split this up. I'm going to make it the integral of 1 over 1 plus x squared dx. Let's not even put the dx in there yet. Let's erase that. Uh-oh, I clicked it. Plus x over 1 plus x squared. And I'll throw the dx on the end. Okay. And now I'm going to split them up into 2 separate integrals. 1 over 1 plus x squared dx plus x over 1 plus x squared dx. Now, I don't know if you noticed this, but this is something that we know. That is the inverse tangent formula. Right? 1 over a squared plus u squared. A is 1, u is x. This one, I can do a u substitution. If I let u equal 1 plus x squared, then du is equal to 2x dx. Pull that 1/2 out, and I get x dx, and that's exactly what I needed here. So this one can be rewritten as, I'm going to pull the 1/2 out, 1 over u du. And then last but not least, I know that this is the inverse tangent of x plus 1/2 natural log of u, which is 1 plus x squared plus c. Like I said, that one was kind of a crazy one. If this was multiple choice, I would expect that you might see that, but I really don't see them doing that. Although it wouldn't be a bad problem because you hit the inverse trig and you hit the natural log. Incidentally, you don't need the absolute value signs here because 1 plus x squared will never be negative. So you can drop the absolute value signs off of that. Okay? For your assignment, I would like you to do the evens. Now, in the a document that I'm attaching, there's, I think, 22 total problems, but you are not doing all of the evens from the whole document. You're only going up to including 8. All right, so after you do number 8, you can stop. And we'll pick up with the document next week. All right, bye guys.